as I said before, let's give credit where it's due. So the SEL 587 manual is where I got a lot of these images from in Appendix F. It's a gold mine for these kinds of resources. Now, this one what we're going to do here is a DY1. And in a DY1, this is going to be hooked up. It's also referred to by that SCL manual as a DABY. And the reason is because if you look at A phase on the secondary, well, that's the Y, right? So that's just A to neutral. And then A phase on the primary, well, that's A coil to B minus B. So that's A minus B, which is DAB. That's why it's called that. Okay. So now we got that established. Let's go ahead and make our transformer connections down here on the bottom. And the easiest one to start with is the Y, right? This is a DY1. This is one of the most common transformers that most people run into. So the secondary is the only thing that's different on this one that most people do run into is that they have a neutral brought out. This one doesn't. That doesn't matter too much, okay? We just hooked up all of our negative polarities. Remember, they're the ones without the dot, right? There's no dot on the bottom of the coils, okay? That's the same thing as saying that this dot right here is on the top side of those coils. There's no dots on the bottom of these coils, okay? It's the same analogy, all right? Same information. So now that we have that, we're going to go ahead, we're going to draw out. This is my A phase. This is my B phase. And this one is my C phase. Cool. So now we have our Y. Now we need to go ahead and draw our primary. And the primary is going to be a delta. And as we said before, all the positive or all the polarity connections go straight out. Okay, so this is A phase. I'm going to use capital letters in the primary, like I did before. B phase, and this one is going to be C phase. And then how do we hook up our negative polarity of these coils? Okay, the negative polarity down here. How do we hook these up? Because A phase can hook up to B phase, or it could hook up to C phase, right? So we need to identify which one's going to hook up to. Well, as I said before, this is a DAB transformer, which means our A phase connection right here connects to the A phase coil and the B phase coil. Well, we know it's not going to connect to the B phase, positive polarity, because that would just be a phase-to-phase fault. Okay, we're not going to be stupid about this. So it means it's going to go from A phase right here, and it's going to jump her down to the negative polarity of B phase. Okay, and you could use that same convention and go from B phase and jump her down to C phase. And does that line up? Well, if we come in B, it goes to the B phase coil for sure, and then it goes down to the negative polarity of C. Yes, that lines up. And now we only have one left, right? We didn't hook up anything on C phase, so it's going to come out right here. It's going to go up, and it's going to go to A phase. Is that correct? Well, this connection of C phase connects out, and it goes to the negative polarity of A phase. So yes, that's good. Perfect. So now that we have that, let's figure out our clock shift, right? Because we always want to get back to figuring out this business, okay? So how do we get that? Well, on the primary, we're got A phase, B phase, and C phase. These are deltas, okay? So when we look at the delta, let's go ahead and draw this out right here. We're going to draw a big delta. Well, that's going to be a reverse triangle. So let's try to draw something a little bit more accurate. There we go. And so this is going to be A phase. And remember, this is rotating in that direction, right? If it had a center point, it's going to rotate in that direction, which means B phase would come next, and then C phase would come next. So there's that. And I always like to imagine that you have your imaginary ground voltages here, okay? And we're just using these as a reference. So there's that. And then I'm going to leave the triangle. I erased it in the last video. Hopefully it's not too confusing for people. So what I'm going to do is I'm going to go now, and I'm going to go back to my actually let's stay on this. So if I am looking at VA on the secondary, right? VA is the same. This voltage right here is, well, what is this? This is going to be my coil voltage, right? Which is A to neutral. And we don't really care about neutral. Neutral is just the ground voltage. So there's no point in identifying it. It's just zero. Okay. So this is going to be A on the secondary, and then our primary voltage is going to be, well, what's this hooked up to? It's A phase to C phase. Okay. So that means that our delta, in just to track that down, right? I'm going to go ahead and maybe I can use a different color here. A phase right here goes out. That's too easy. And then this one, we're going to trace this down, comes across, and it bonds to C phase. Okay. So there's that. So let's go ahead and let's write that out right here. Our V, let's put it out of the way because we're gonna need space. So VA is equal to, right? It's gonna be equal to our V big A to C. Okay, VAC. That's what this coil is. It's A to C voltages, which is the same thing as VA minus VC. Okay. And so what is VA minus VC? Well, that means that we're going to take the A phase vector, right? And we're going to add to it the negative or subtract the C phase vector. So the C phase vector is in this direction. We're going to subtract it, which is the opposite direction. Okay. So that means that we're going to do A phase plus a C phase minus negative C phase, right? So what's that going to look like? Well, when you superimpose that, that's going to look like A phase here plus a negative C phase, which is over here, okay? And what does that do? Well, that gets us a total vector sum right there. And so this is going to be V little a, okay? So that's how you get that guy figured out. And then we're going to have the next one, which is VB. And I see that I'm clearly running out of space here. And so VB, I'm gonna do VC over here, is equal to, right? And we'll just get them all drawn out. So what is VB? Well, the VB coil is right here, right? V little b. That coil is right here. And it's getting induced from B phase. And if you trace the other one out, it goes all the way up to A phase, right? So VB minus A. You can also look up here and you can see that the B phase coil is right here. And the positive polarity side is connected to B and the negative polarity side is connected to A. Either way, you could draw it both ways. I just wanted to show that. So this is VBA, which is the same thing as VB minus VA. Okay. And we'll get that one drawn out here in a second. I'm in red, so might as well keep using this color. And so what's VC? Well, that one is right here. And actually, let's just start it from this one up here. So this is my C phase to ground, right? And ground is 0. That's our reference point that we're using for all of this. That's why I wanted to use that 0 right there. It's a good reference point. So if we use C, well, the C phase coil is this one right here, right? And on the positive polarity, it's C phase. And on the negative polarity side of that coil, it connects over to B phase. So this is V big C minus V big B. All right. Now we've got all that figured out. So let's go ahead and draw this, right? So what is V little b, right? That's going to be big B minus big A. So big B is right here, right? And then we're going to do minus big A. Well, A is right here, right? But we need minus A, which is down, which is straight down, okay? So what that's going to end up being is this is going to be an arrow like this plus an arrow that goes straight down, okay? So that's what we call superimposing. We go right on top. That's this arrow, that's B minus A, which is straight down. And then we're going to go ahead, we're going to draw the total sum, okay? That's the total, which is V little b. Now we have one more to do, which is VC down here. And that guy is going to be big C minus big B. Well, big C is right here. And I think you get the drift. Big B is going to be straight up this way, right? Because this one is down to the right. We don't want that. We want one that's up and to the left. So the total, which is actually supposed to be more flat right here, is right there. So you look at this, what you have is you have 30 degrees here, or one clock shift, right? 30 degrees, and then another 30 degrees. Well, what is that? One clock shift, positive or negative, right? Well, let's go ahead and get that back out of here so that way we could clear up all this this stuff that we got going on here. And what you'll see is that this vector diagram, I didn't label this is V little c. This vector diagram, the triangle right here and the y are exactly what you see right there. Okay, so that means that this guy right here, and what they did was they did us a favor. Our A phase delta is pointing straight at 12 o'clock. Okay, so that means that this guy right here is at 1 o'clock. And lo and behold, that means we're a dy1. Okay, because the delta is always the reference angle. It's always at 12. The y is at 1. We don't care about writing the 12. We'll just get rid of that. We'll just take the 1. We'll put it right here. Now we know if this had more windings on that transformer, it could be a dy1, d0, which means that you have another delta on top of this, lined up directly on top of this one, and it is also A, B, C, and it would have another coil, like it were to come out of here, it would have another coil, and that is going to be connected the same fashion as this one over here. Okay, so that's how you get to the tertiary transformers too.